All right, so last time we talked about elimination, and the last time we talked, we always had a pair of variables that had the same or opposite coefficients, meaning they either had the same coefficient or they had opposite, as in one was positive and one was negative. Now, we're on the note sheet from last time because if you don't have your notes written down specifically, these steps right here in the middle, then you need to write those down. You need to have those in your notes. You need to keep those handy because they're still going to come into play today. So as a prerequisite, make sure you have these 4 steps written down because we are going to build off of those today. And what I mean by we're going to build off of those, I mean we're going to insert a new step right there between steps 1 and 2. So let's get into that. So today for 2B, we're still dealing with elimination, but we ask the question, what if there are no common coefficients? So what if, for example, like number 1, we have a coefficient of 1 for x, we have a coefficient of 2 for x, we have a coefficient of 3 for y, and we have a coefficient of -7 for y. Well, we can't just add or subtract those and make them go away, unfortunately. So we have to ask ourselves what we need to do if there are no common coefficients. And the answer to that is we need to multiply, and I'm going to say multiply or divide because in some cases you can divide and it works out well. That being said, you could always just multiply the other equation by 2, but whatever. So you can multiply or divide one or both equations So you multiply one or both equations by a number or numbers, if you're multiplying 2 equations, to create matching or opposite coefficients. So multiply or divide one or both equations by a number or numbers to create matching or opposite coefficients. So what that means is, like this example in number 1, we don't have any matching coefficients. But I can see we have a 1x, and then on the top equation we have a 2x on the bottom equation. So what I'm going to choose to do is I'm going to multiply this top equation by 2. And what that's going to do for me is it's going to leave me with 2x plus 6y, because 2 times x is 2x, 2 times 3y is 6y, equals 12. So it's really important to make sure you multiply every single term, not just the specific variable where you're trying to change the coefficient. You have to multiply it all the way through, or else it'll get messy and it'll just turn to deep, dark math sadness. So now our top equation has been transformed into 2x plus 6y equals 12. So now, second piece, I'm just going to copy this second equation back down. So we have 2x minus 7y equals -1. So we have those copied down. Now, what we do at this point is we're going to follow the remaining 3 steps from yesterday. So we need to decide whether we add or subtract. Looking at the coefficients on the x, I can see they're identical. Since they are identical with the same sign, we need to subtract. 2x minus 2x is 0. 6y minus -7y, since there's a minus sign in front of it, would be 13y, or positive 13y. 12 minus -1 would be 13, because that's really like 12 plus 1. So we are left with 13y, because I can just ignore that x. 13y equals 13. Divide by 13 on both sides. Cancel, cancel. We're left with y equals 1, which is delightful because that's half of our answer. Y equals 1. Now we have to plug that in to one of these equations. I'm going to plug it into the top one. So I'm going to say x plus 3y equals 6. Now I'm going to plug in that 1 for y. So x plus 3 times 1 equals 6. X plus 3 equals 6. Subtract 3 from both sides. We're left with x equals 3. Now all we have left to do is write this as an ordered pair. Our x value is 3, so that goes first, comma, our y value, which is 1. Boom. And our final answer is 3, 1. So that would be a location on a graph. Because, of course, we could solve this system by either substitution or graphing as well. Okay. Let's look at another one. So let's look at number 3. We have the equation 3x minus y equals 14 and 5x plus 4y equals 12. So we have choices. What I see when I look at this is I see the y variable in this top equation has a coefficient of 1. And I know anytime I have a coefficient of 1, that's super easy for me to multiply wherever I need to get it. Because I know 1 times 4 is going to be 4, so that would give me matching coefficients with the bottom 4y. So what I'm thinking in my head is I'm going to multiply this top equation by 4. And when I do that, I'm going to get, I shouldn't do an equal sign. We'll just kind of give a little line there. 4 times 3x is 12x minus 4 times 1y is 4y equals 4 times 14 would be 56. So then I'm just going to copy this equation straight over. So we have 5x minus plus 4y equals 12. Okay. So now we return back to our steps from yesterday, and we need to decide whether we add or subtract. Now, my coefficients I'm looking at in this case are attached to our y variable. And if I look at the first equation, I have a minus 4y. On the bottom equation, I have a plus 4y. Since we have opposite signs there, what I'm going to want to do is I'm going to want to add these equations. So I have 12x plus 5x, which is going to be 17x. Negative 4y plus 4y is going to be nothing. And then, so I can put plus 0 if I want, but it's really totally unnecessary. And then 56 plus 12 is going to be 68. Now, my last step, if I just make this look pretty, 17x equals 68. I'm going to divide both of these by 17. 17x divided by 17 is just x. And 68 divided by 17 is going to be 4. So I know my x value is 4. Now what I need to do is I need to plug it back into one of my initial equations. I'm going to plug it into that second one. I don't know why, just because I got a good feeling about that one. So I'm going to rewrite my original equation, 5x plus 4y equals 12, and then I'm going to plug in that value. So 5 times x, or 5 times 4, plus 4y is going to equal 12. 5 times 4 is 20, so 20 plus 4y equals 12. Subtract 20 from both sides. I'm left with 4y equals negative 8. And if I divide each of those sides by 4, I'm going to be left with y equals negative 2. So now I have both an x value and a y value. Now I'm going to write those as an ordered pair, my x value being 4, so it'll come first. Then my second value being the y value of negative 2. Okay. Let us know if you have